Sir,
What will the exam be? Oral exam or written exam?
it's a written exam, an online exam. Um, I already registered some exams for you in the Neptune system, and there you can find a short description how the exam will happen. So in a nutshell, it will be online, it will be a test, and you have to write your answers on a sheet of paper. Then you have to take photos of it and upload the photos.
So we don't need to write online for suppose.
No,
Okay.
you have to upload those photos, pictures.
And we don't have oral?
No,
Oh,
not in this semester. So
okay.
I'm simplifying the exam a little bit for you.
Yes, sir.
I hope you don't mind.
No, sir, we don't mind. And did you, sir, upload the topics?
Yes, let me share my screen with you.
Yes.
Okay, so you can see the e-learning site here. You can find the exam topics. They are the same as in the previous semester. And I will give you, in the test, I will give you, um, I mean, I will give you questions from those topics. For example, I will tell you what are the rules of inheritance and compare those rules with Java and C++. Or I will ask you, I don't know, what abstract classes look like and what is the relation with constructors, for example. So I might combine those topics in as well. I will give you 4 questions. You have to write the answer, upload the photos, and that's it.
Yes, sir.
And it's important that there will be a time limit of, I don't know, 20 minutes. So you have to answer all the 4 questions in 20 minutes. So this will be a little bit time critical because I would like to avoid cheating, and you are not supposed to use any help by anyone else. So this is why the test will be time critical. There will be a time limit.
The question will be short, sir?
Well, the questions will be short, but you have to write an answer. The answer will be a short essay. So a
Yes.
text. You have to write the answer as a text. This could be a little bit longer, but I guess you can write the answer in 5 minutes for each of the questions, and this is how 20 minutes. I count 20 minutes for 4 questions. Okay, I will send you an Neptune message next week about the very details, where and how you can join the exam, because the exam will be run in the e-learning site, but meanwhile we will use Discord. Do you use Discord?
Yes, sir. I
Okay,
have.
okay. So I will send you an invitation link to my Discord server as well. Next week, I will send you a Neptune message about the exams. And it's very important that you must pass the exercise class with Mr. Kusper. If you don't pass the exercise class, you must not take the exam. Passing the exercise class is a prerequisite for taking the exam. Today, I would like to finish the last topic. You know, the last topic is about lambda expressions and LINQ. Last week, I was talking about lambda expressions only. So today, I'm planning to talk about LINQ. Okay, so let's see what LINQ is. LINQ is an abbreviation of this English term, language integrated queries. So basically what we are going to do is that we will query from collections of data, for example, from databases or from lists. And as far as I know, you already know something about SQL, right? Databases, SQL. Do you have such a course now?
Yeah, we have database system.
Okay, that's it. So okay, so you know how to run SQL queries from databases. So now we will learn how to do similar queries in C#. Those queries will be integrated in your C# program. This is kind of interesting and kind of unique in C#. You cannot really find any similar tools in other programming languages. Well, that's not exactly true. For other programming languages, for example, for Java or Python, there are extensions, libraries to make queries from databases, for example, but those queries are not really integrated in the language, in Java or in C++. In C#, you can integrate all your queries. And I will show you why this is why this is very interesting and why this could be beneficial. Okay, how to start this? Okay, I will show you two demos today. First of all, I will show some LINQ queries within this program I used last time. So I hope you remember. In this program we have this form, and on this form I'm trying to display real estate data. I have a lot of buildings, farmlands, in general real estate in my txt file. So I'm opening this file from the program, I'm reading all the real estate records, and I'm listing them in this list box. So far it works like that. Last time I was, there is some mistake here. Okay, this is something new I added recently. So here you can find all my real estates read from the txt file. This is the ID. These are the IDs. These are the prices, and these are the other details of the real estate. For example, what kind of real estate this is, what is the address of the real estate, what's the area of the farmland, and so on. So last time I showed you how to sort those elements, and therefore I extended my container class here with this method. In this method, I showed you how to use a method from the list class. You know, this is a list, the list class. And I was passing a lambda expression here as a parameter. So this is a lambda expression with 2 parameters. And we are using lambda expressions all over the program. For example, here we use one with 1 parameter. And as far as I remember, yeah, here is another lambda expression with what parameter. Here is another one. So you experience that lambda expressions are really cool, really general purpose. You can use them really nicely and in a very intuitive way. Anyway, back to my container class here. So now I would like not only sort my real estate data, but I also would like to filter my real estates or sort them in another way. I would like to do something similar to SQL. So, you know, in SQL, you can filter in the query with the where keyword. You can sort by using the order by keyword, and you can do so many stuff in SQL. And I'm going to do something similar here, but this will be really interesting because now I'm filtering and ordering over a list, not over a database. So this is different from SQL. Now I have a collection inside a list. So now I'm going to show you how to do SQL-like operations on the list. I hope you are ready, you are listening. So I'm thinking about introducing a new method here instead of these sort elements. This method can only sort. So now I'm thinking about introducing another method. Let's call it prepare elements. Inside this method, I'm going to execute a lot of preparation operations like filtering, sorting, and so on. Okay, so first of all, let's do such a operation. So let's look for interesting methods inside the list methods. I'm looking for methods which are very similar to SQL keywords. So if I'm browsing here, this list, I can find like distinct. I guess you learned the distinct keyword in SQL, or like join. I guess you learned how to join 2 tables. And here you can find order by, you can find select, you can find where. Yeah, where. So now I would like to filter my list. In SQL, you know, where the where keyword is the one you have to use for filtering. So let's try it. Now let's filter the real estates based on their prices. So I would like to filter out the cheap real estates. How to specify this? So here, basically, if we check out this window, we have to pass as a parameter a function by using this func or func type. So this is something we learned about last time. This is a delegate. This is a delegate, which takes type parameters. The last type parameter is the return type. The type parameters before this are the types of parameters. So let's check out this func here. So the system requires from me a function which returns bool here and has a single parameter real estate. Basically, I have to write a function which takes a real estate as a parameter and returns a bool value, a true or false value. Okay, let me show you how to do this. So if I'm using a lambda expression here, I'm going to have one parameter. The parameter, you see, the system already inferred this. The type of the parameter is real estate. And here I have to write some expression of type bool. So a bool expression, the one I have to write here. A true false expression, basically a condition. Okay, Rasul just arrived. Let him in. Okay, for example, now I would like to filter my real estates based on their prices. And as I already told you, I would like to filter out the cheap real estates whose price is lower than, I don't know, the prices are in Hungarian forints, so 12 million Hungarian forints. This is considered to be kind of cheap. Okay, so I hope you understand. This is a condition of type bool. This is what I have to put there on the right-hand side of my lambda expression, and that's it. I'm done. I filtered my list. Okay, if you don't believe me, let me display the result here in the list box. Yeah, but this requires further preparation. So first of all, I have to return this list, this filter list here, which means void is not appropriate here. So I have to check what is the return type of this var method. It's something like enumerable over real estates. So the return type should be enumerable over real estates. I hope you remember what enumerable is. It's an interface, all right? Anyway, so basically I have to return an enumeration of real estates. This sounds kind of logical. Okay, then back to my form. So here, instead of calling the sort, instead of calling these two lines, I was planning to call my new method. You know, this is called prepare elements. This is what I just implemented here. And this returns something, so I must store the result in a variable of type, of type what? Of type I enumerable over real estates, like that. Okay, here I retrieve the result of the query. And now I have to display the result here in this list box. So this is the last step now. So here I must do something similar to this line. I have to execute some action for each of the element of this result. So let me show you how to use a built-in, Melinda, let me show you how to use a built-in method for this. I'm not going to use my method, which I implemented before. I'm not going to use this one. Rather, I'm going to use a built-in method for a similar purpose. But this is not that easy. Okay, beforehand, I have to use a magical method here to list. So I have to convert the result into a list like that. Later, I will talk about this magical method. And now, look at this. I can call a very special method of my list, which is called for each. If we look at the help message here, so the for each method performs some action on each element of the list. This is what I need. I have to perform this action on each element of the list. This is how how the elements of the result will be added to this list box here. So let's see what this for each method requires as a parameter. It requires an action of type action. So we learned about the action delegate last time as well. The action delegate can represent basically a procedure which returns nothing, returns void, and takes some parameters of type we specify here in between those special brackets. So if we look at the help message here, this for each method requires an actions on a real estate, over a real estate. Okay, to sum up, we have to execute the very same action here, over a real estate. But now we pass this action to a built-in method called for each. I just wanted to show this to you because lots of time you don't have to implement something by yourself. First, I suggest you to look for similar methods in the .NET framework, and now I found a similar method, the for each method. Therefore, this method which I implemented before is not needed anymore. Okay, let's look at the result now. Yeah, okay, this is correct. So if you remember, I filtered out the real estates whose prices are lower than 12 million Hungarian forints. And actually, if you check out the prices here, yes, you can see only prices which are lower than 12 million. So it seems working. Of course, we can test it more further. So let's set the upper limit lower to 8 million. You see, it works. Okay, I hope you like what you see now. And you might found my explanation a little bit complicated. Okay, it might have been a little bit overcomplicated, but now I will show you that using those methods such as where, order by is so simple. So let me show you now that I can also give another filtering easily. I'm just using another call for this where method, and now let's filter out only the buildings. If you remember, here in the list, I have houses, buildings, like this family house, 2 family houses, and there is a third one here. But the rest of the list are not buildings. Here I have a forest and 2 real estates here, which are undefined. They are not buildings, but of some other kind of real estates. So let me just now filter out only the buildings. Let me put this filtering in a new line here, like this. Okay, let's check it. Let's check this out. You see, now only the buildings are filtered out, which are cheaper than 12 million Hungarian forints. So I I use two filterings, one after the other. Okay. Okay, so it is very common that we call those SQL-like methods in a chain. Here is one, here is another one, and I can continue with other SQL-like methods, like let's order the result here. So let's order the result based on their prices. Okay, how to do this ordering? Sorry, so here I use a chain of methods. Each of them is follows a dot operator, of course, and this is a nice way of enumerating all the method calls. Each of them, you can put each of them in a separate line. I hope you like it. Okay, so ordering. How can I order the list based on the prices? So let's see what this ordering method requires a parameter. Well, it's a function again with a real estate parameter, but now the return type is not defined. It really depends on which property of my real estates I choose for the base of the ordering. So for example, what if I would like to use the price as the base of the ordering? Then the type of the price is a uint. So in this case, the return type will be, the return type of the function will be a uint. But of course, I could use other properties, another property of my real estates. For example, I could use the ID for ordering, and ID is a string. So in this case, the ordering depends on a string comparison. Okay, so now let me use the price for as the base for the ordering, and that's it. This is all you have to do. You can use such a lambda expression to define the base for this ordering. Okay, let's give it a try. Yeah, exactly. So now my real estates are ordered based on their prices in an ascending order. Do you have any questions so far? No?
No, sir.
Have you ever used those methods before?
No,
Yes,
sir.
no? Nobody? Okay. It's not that difficult to find them. So again, if you have a list, just browse the methods of the list and you can find those methods and similar methods. For example, you could ask how I can order my list in a descending order. So if we check out the list of methods, you can find such a method, the order by descending. That's it. Now you see the prices are descending. So this is so easy. These methods in the list are so intuitive to use, especially with lambda expressions. I hope you agree. This is why they were invented in LINQ. So these all are LINQ methods. LINQ is basically LINQ is a namespace, system.linq. This is the full name of the namespace. And from this namespace, the list class is extended with new methods, with such SQL-like methods, and also arrays and other enumerations. So in fact, not the list class and not the array class are extended, but the interface IEnumerable, because this interface, this interface serves as a basis for arrays and lists and dictionaries and stacks and queues, so any kind of enumerations. All those classes, such as the list class, implement the IEnumerable interface. Therefore, the systemd_q namespace extends this interface with the where method, with the order by method, with the order by descending method, with the select method. Okay. Okay, let me show you this table with such methods. Here I try to classify those methods. So, for example, you already know that the where method is for filtering. We already know that the order by method, and that is something which we call then by, are for ordering. So they are in this ordering class. I will talk about the remaining methods, but let's give the then by a try. Okay, so then by. Here in my program, I ordered my real estates based on their prices. And now actually I have two real estates on the top of the list with the same price, right? I would like to, how to say, I would like to introduce a secondary ordering. So if several elements have the same price, I would like to order them based on their addresses, for example, here. So I would like to put the one whose address starts with B first, and then the next whose address starts with N. So I would like to swap those two. I would like to put them in an alphabetic order. So this is a secondary ordering. This is for what you can use the then by method. So let me implement this now. So here I would like to apply a secondary ordering by using the then by method. And actually the parameterization of the then by is the same as that for the order by methods. So I have to use a lambda expression and specify some property here as the base for the ordering. So I told you I would like to order now by their addresses. And unfortunately, I cannot find any address here, which is, yeah, I know why this problem happens. So in my program, I have this parent class, real estate. The real estate only has an ID and a price and no address. Then I introduced child classes, for example, the building class. This is the child class of the real estate class, and here I introduced the address property. So only buildings have addresses, not real estates in general, because there can be some real estates which don't have any address assigned yet. Okay, so the problem is here that, that the type of X is real estate and there is no address property inside the real estate class. But actually, at this point, I can be pretty sure that I have to deal only with buildings because I did such a filtering. So after this filtering, I have only buildings. Therefore, here, it's logical that X must have an address. So therefore, I would like to use another method here instead of this second filtering. So please meet this very handy method of type, what does this do? Let's see. So of type filters the elements of the enumeration. This is all right so far, based on their types. So basically, I can filter my elements whose type is specified here as a type parameter, and there are no further parameters basically. So this performs a filtering. It filters out only the elements of this type. The other elements are removed. And what is nice now that after this filtering, look at this X, the type of X is already a building. So the C# compiler is quite smart here. Since the type of X is a building, it has now an address, you see? So I can do my address-based ordering. I hope you understood. I have 1 minute before disconnecting. Let's check out the result. Okay, now it's correct. So again, the ordering, I have a descending ordering based on the prices. And if I have several elements on the same price, then they are ordered based on their addresses in an alphabetic order, of course, here. Actually, I hope you find this kind of easy to use SQL like filterings, orderings, and you will see you can do much more. What you have to know are lambda expressions and those special methods, and that's all. Basically, this is supposed to be so intuitive to use, so declarative. I already mentioned this last time. Okay, so let me show you this table again. You can see the select method here as well. So you know very well from SQL that selecting the columns or properties of the records you retrieve as the result of the query is very important. You learned how to use select star if you want to retrieve all the properties, but of course you can select specific properties as well. And this is something you can also do in LINQ. I'm not going to show this to you. If please search for this in the internet and check out some tutorials. You can also do joins. I will show you some demo soon with joins. Of course, joining enumerations or data tables is also very important. I guess you also learned about the group by feature in SQL, so you can do the same in LINQ. So there are so many opportunities here. I made the most important methods, bold here. So where, select, order by, then by, these are really important. Also, any and all are important ones. I'm not going to show you a demo with them, but you learned about logic last semester. I know you did. And you learned about quantifiers, universal quantifier and existential quantifier. Here in LINQ, you can use the all method as for universally quantifying and the any method for existentially quantifying. If you are interested, please look this up in the internet. Okay, also, sometimes it's very important to do partitioning on your result. Just imagine that you query from a database and several thousands of records are retrieved. It would be really a bad idea to retrieve all those thousands of records at the same time. So we would like to do partitioning. We would like to split that huge number of records into smaller partitions. For example, just imagine that you implement a web shop, and the user does some query, and it would be a really bad idea to display all the thousands of elements on the web page, right? You want to split this list into pages, several pages. And for this, you can use the take and skip methods. The for the take method, you can tell how many elements you want to take. For example, only 20 elements at the same time. And then the user can jump to the second page, the third page on your web page. Therefore, you also need to skip the elements you already displayed on the web page before. Again, if you are interested how to use the take and skip methods for partitioning, just search for them in the internet. Okay, what else are important here? You can retrieve. Okay, sometimes you don't even want to take all the elements, or you don't even want to partition the result. You want to take only the first element, for example, or the last element. This is something also you can do. Sometimes you don't even want to retrieve any elements. You only want to know the count of elements. I guess you learned how to retrieve the count of elements in SQL. So you can do this also in C#. I guess you also learned in SQL how to retrieve the sum or the minimum or the maximum of elements or the average. There are dedicated functions in SQL for those, and so does LINQ. So for example, now, okay, sorry. So these kind of functions are called aggregation functions. They don't retrieve any elements, but only a single value, a number like the count or the sum or the average. Let me show you how to use this now. So for example, here on the form, I would like to retrieve the count of elements. That's all. And this is something I would like to display on the form somewhere. Like I'm going to open a message box. This is the easiest way of displaying something on a form. And let me just show it in a nice way using string.format. And this is the text, the count of resulting real estates is okay. So here I use an aggregation function to retrieve the count, and let's see if this works. Yeah, okay, there it is. Sorry, of course. Yeah. So first the message box is shown. It shows 3, and then the entire form opens. But of course, you can do something else here. You can also use, for example, the average function, which is also an aggregation function, all right? But this, I guess this requires some parameter. Oh, right. So it requires some lambda expression again, a function that takes a real estate as a parameter and returns a decimal number. Decimal is a huge integer, floating point number. So anyway, you have to write a real lambda expression with a real estate parameter, and then on the right hand side you have to specify some numeric, like the price or the area of the real estate. Now let's calculate the average price. So this is it. I'm calculating the average price. That's all. Okay, now this is the average price, okay, with several decimal, what are those? So it's a floating point number. Okay, so this was the average price of those three real estates. Of course, you can also calculate the sum if you want, no problem, or the minimum or the maximum. Okay, so this is the sum. Let's check out the maximum now. Yeah, of course, the maximum is 5,100,000 Hungarian forints, and actually it's correct. Okay, then, so these are the aggregation functions. They are easy to use. Actually, let me just update this text. Sorry. Okay, so they are easy to use. Okay, two more important methods here: toList and toArray. Actually, I already used the toList method. If you remember, here, and I told you this is a magical method I had to use there. Well, let's see what this magic does. Well, it says this is some conversion method, and the magic behind conversion is explained in this subsequent slide. In this slide, first of all, there is something you already know. The calls of those methods can be put in a chain. This form of chaining is much nicer, and this was the chaining I used here actually. Okay, this is something you already knew. What you did not probably know, sorry, is this. And here at the end, I'm going to use the list. So LINQ is sometimes slow. Okay, in a minute, I'm going to respond to Rasul's question, just a minute, but let me finish this slide first. So here, LINQ works slow sometimes. If you have thousands or even more of objects, then LINQ can slow down. But also, in order to avoid this, LINQ uses something which we call lazy evaluation, which means that typically we don't want to retrieve all the elements in my result, all the thousands of elements, but only the elements I currently need. So by using lazy evaluation, LINQ returns only the next element, only if I ask for it. When I ask for it. And actually, this is suggested by the name of the interface, IEnumerable. So you cannot really, but if you use LINQ, you cannot really access all the elements in the result of a query, but you can access them one by one, after each one after each other. But sometimes we must access all the elements now. In such cases, we have to convert the result to a list or to an array. You know, you can access all the elements of a list or all the elements of the array instantly. So this, if you want to avoid lazy evaluation, you can use those conversion methods. You can convert to an array, to a list, or to a dictionary. In my program here, I had to convert the result to a list because I wanted to access all the elements, because I wanted to execute an action for each of the elements, right? So this was the explanation here. It's really pity that you didn't learn about SQL, but if you didn't, then even then you will understand why the syntax I'm going to show you now is nice. So I showed you how to use those extension methods, but there is a even nicer way to use them. So now I'm going to use a completely different syntax, a much nicer syntax for the same. Just look at this. Let me first write the same query in another syntax. So for this, I'm going to use a built-in keyword from. Okay, from X in real estates. This is how I start. I will explain this to you soon. And then select X. Okay, so now I use a radically different syntax for retrieving elements from an enumeration. Here is my enumeration. So I'm retrieving elements in this enumeration. X denotes the current element. And now I'm selecting this element. If you know something about SQL, this is actually a select star operation over this list. So if I execute now the program, you will see all the elements, all my real estates in the list box. So now I retrieved all the elements. Now I would like to do the same filterings, you see. So for example, I would like to select filter only the real estates whose price is lower than 12 million. How to do this? Well, it's easy. X is my real estate. I check out its price, and I compare it against this constant. That's it. Let's check this out. Uh-oh. Sorry, 10 is missing. This upper limit was too low, so there were no elements in the list. But now I have I have okay 6 elements in the list, which are not more expensive than 12 million Hungarian forints. Okay, and let me do some ordering here. There is an order by keyword. And you know, I would like to order my elements based on their prices. This is what I do. It works. Now everything is ordered by their prices. It's easy to do descending ordering. There is such a keyword as well, where I have to put it there. Okay, now they are ordered in the other way around. Okay, so let me tell you what this is. This is again a radically different syntax for the same. So if you check out the previous piece of code, in this code there are so many irrelevant details. For example, I used a lot of lambda expressions. Each of the lambda expressions has the same left-hand side, here and there and there and there. So why not eliminate this left-hand side and also the arrow? Actually, this is exactly what I did here, right? Or instead of calling methods with the parameter list, why not to use keywords for this? This is really similar to SQL, by the way. So these are very high level, very easy to understand keywords, which can be used only for querying from a list, from a database, from any enumeration. So I hope you find this even nicer than the previous syntax, but actually the purpose is the same. And everything is, so this query is integrated in my program, in my source code. This is very important. This is why we call this technology LINQ. My queries are integrated in the language, in C#. So this is also C#. It might be surprising. This is C# code. Everything is integrated. So if I check out the types, I can see what the types of my variables are, what the types of my properties are. I can use the same operators I got used to in C#. I can also combine this kind of syntax with some old syntax. For example, here I have to run another filtering. Unfortunately, the off-type method doesn't have a counterpart keyword. Therefore, I must call it in the old-fashioned way. The very same way I did this before. So first I filter only the buildings, and then I run all the remaining filterings and orderings by using this cool new syntax. Yeah, okay, let me put another ordering here. You see, I also have to order by the addresses, and now this is already possible because the type of X is building because of this method call here. There is no then by keyword. I can use several order by keywords in this new syntax. So basically, I'm going to use the address for secondary ordering. That's all. And I hope it works. Okay, now you can see the very same. Oh, no. Interesting. Something is not okay now. Since the primary ordering should base on the prices, and the secondary ordering should base on the addresses, and now the address-based ordering seems to be the primary one. Interesting. Interesting. I don't really understand why this happens now. Okay, maybe I have to switch the orders, and this is the primary one, this is the secondary one. I didn't know that. This is new to me. Okay, interesting. Okay, do you like this new syntax for queries? Or you feel neutral? You feel neutral. Okay, then. Okay, so I'm not going to show you, I'm not going to extend this program anymore. You can just keep going. You can try other orderings, other filterings. Actually, there are several other keywords, like you can join lists together, you can group the elements by using the group keyword. If you are interested, just look this up in the internet. Like I'm looking for LINQ syntax now. I just found a tutorial here, and Okay, here is another example which looks very similar to mine. Here you can see also that you can combine well-known methods you already know inside the filtering area or the ordering area. I will show this to you soon. And okay, maybe this tutorial is not as detailed as I imagined that. Okay, and here you can see some of the other keywords: order by, the ascending keyword, the group keyword, like this, query keywords. Okay. Okay, here they are. So there are several such keywords, not that many, fortunately, but quite a lot. They are really similar to SQL keywords again. Okay, I have 10 minutes left, therefore let me open another demo. Now I will show you a demo which queries not from a list, but from a database. I don't know what kind of database you learn in your database class. What is it? Microsoft SQL or MySQL? MySQL, okay, great. Okay, I'm using now also MySQL. So I have MySQL installed on my computer. And let me check out the workbench. Didn't you use the workbench for MySQL? Okay, so here I have a database consisting of several tables. For this demo, I filled only 3 tables. I have a customer table with lots of data of customers. Each customer have first name, last name, and I don't know, email address, phone number, and so on. I also have an address table with addresses. And I also have a third table, which is an intermediate table between the customer table and the address table. I don't know if you learned about these kind of tables which serve as a bridge between 2 tables. So the customer address table is of this kind. Anyway, in the program, I will do some query here. For example, I will list all the customers. So this is how in LinkU I can access the customers table. I'm not going to give more details on this. And let's just retrieve all the customers now. And let's write all those customers on the display. This project now is a console application, so I will write everything on the console. So for example, here I will list the first name and the last name of the customer, like that. Okay, so again, I have now a database, a MySQL database. This database could be on a completely different machine, in a server machine, for example. It's kind of easy to connect to this database from my C# code by using LinkU. And it's kind of easy to make queries from the tables in that database. So let me just execute this program now. If everything worked out, I can see all the customers here. There are so many. So I could also write here how many customers I have. This is aggregation. And here I can use some aggregation method. So let me just display the number of customers, the count of my query, which can be retrieved like this. I already showed you how this works. So let's see how many customers I retrieved. Okay, there are more than 800 customers in the system. I will run out of time, but I would like to ask you to reconnect again. So I have 3 minutes left, then I will disconnect and reconnect again because I want to explain you some more details before the end of my lecture. Anyway, let me continue. So let's do now a filtering. Okay. So I would like to filter certain customers, like based on what? Okay, let's filter out the misses. You see, there are Misters and Misses. So I would like to filter out only the misses. So each customer must have a title. Okay, let's see. So here is my current customer. It must have a title. It has, okay. And I would like to filter the misses. So if I check if this equals to misses, right? Right. Okay. So let's see how many misses I have in my database. Okay, more than 300. Okay, this worked. Let's do another filtering, like I don't know. Let's filter the women whose first name starts with A. Okay, these are all the Anns and Amy's and Alice's, 23. So if you, I hope you can see it's kind of very easy to assemble such queries. And again, it's easy because my query is integrated in my source code, and therefore I can combine the query from the database with C#, with .NET. So for example, here I'm using this starts with method. This is a method in the string class. The string class is inside the .NET method. And I'm combining this with my query. Also, let's do some ordering. Let's order, I don't know, the customers based on their name, based on their last name. Okay. So here I'm going to use a string comparison as it is implemented in the .NET framework. Yeah, you see, all the names are ordered by their last names. Of course, I could do this in a descending order as well. It's easy. Okay, it works. Okay, so I have only a few minutes left. Sorry. Therefore, I would like to talk about my last slide here, which is about the var keyword. I guess all you already met this guy before. Actually, I also use this keyword here and there. What is this keyword? Whenever you are too lazy to write the type of a variable, you can use the var keyword because first of all, sometimes it's not easy to find out what the type of a variable is. For example, if you look at this query, you can ask what the type of this query should be. How can I figure this out? It's not that easy, right? Now this part looks completely strange and we don't know really anything about the return type here. But actually, this is something the system, I mean the C# compiler, can find out by itself. The system can infer the return type automatically most of the time. So whenever you are too lazy to put the actual type in front of a variable, you can use the var keyword if you have a assignment and something on the right hand side. In this case, the C# compiler will look at the right hand side and infer the type of that right hand side automatically. So for example, now it was inferred that this query variable has this type I ordered queryable. Never heard about it. Who cares, right? Or it was inferred that here the type of the variable is a customer. Okay, so yeah, this is something I also wanted to tell you at the end. And this is my last slide during the semester. So we reached the very end of my slideshows. Congratulations. One more minute left. I would like to mention that by using such queries with LINQ, you can do so many stuff over databases or over any data collections such as lists. Just a minute. Okay. For example, here you can see a kind of complicated query. Since you have not learned about SQL, I mean, not that much, you don't really know what joining means, what joining of data table means. Here, I use several tables, not only one table. Here, before I use only one table. If you have to use several tables, one table, two table, this is the first table, second table, third table, you have to join them. And this is some example of this kind. I'm going to also group the resulting objects now by using this grouping. So for example, if I execute my program now, the customers are grouped based on the cities where they live. For example, in Ottawa, I have 3 customers. This is what we call grouping. Yeah, I ran out of time. So at the end, I would like to summarize that LINQ is really cool if you want to query from any kind of data collections, and those queries are integrated in C# in the language you learned throughout the semester. Okay, at the end, any one of you has any question to me? Okay, yeah, Rasul asked if I share this code. Yes, okay, I will share this these 2 projects on the e-learning site. Okay, so you will find them. Let's say here. Okay, under this link. Thank you. Okay, and as I told you, I will send you a Neptune message about the details of the exams. So see you soon. Try to pass your your test in the exercise class. I would like to emphasize, if you don't pass your exercise class, you cannot come to my exam. So you must pass your exercise class. This is a prerequisite for the exam. But I think I already mentioned this to you. Okay, so see you soon. Bye-bye. Have a nice day.
See you. Thank you, teacher.
Thank you. Bye-bye.